In this video, I'm going to be talking about the multiplication of Surds. If you're new to Surds, I encourage you to check my other videos on Surds. But here, we'll be talking about the multiplication of binomial and monomial Surds. But first, let's see how we can answer this problem. The square root of 243 multiplies all of these, all divided by this. All you have to do is to take each of the monomial Surds you have in the question and see if it can be reduced to their basic forms. This goes as 81 multiplied by the square root of 3, and this goes as the square root of 9 multiplied by the square root of 6, and this goes as the square root of 625 multiplied by the square root of 2. Now for the square root of 6, it remains as it is. Then this goes as the square root of 100 multiplied by the square root of 3 multiplied by the square root of 9 times the square root of 2, and that is for 18. The next step is to make simple divisions. You can obviously see that the square root of 6 divides the square root of 6, and the square root of 3 divides the square root of 3. The square root of 9, which is 3, divides the square root of 9, which is 3 as well. Then the square root of 2 divides the square root of 2. So we are left with all the perfect square under the radical sign. The square root of 81 is 9, and the square root of 625 is 25. This divided by 10, which is the square root of 100. So here we have 5 dividing 10 2 times, and 5 divides 25 5 times. So this is equals 45 divided by 2, that is 22 and a half. So we're looking at the multiplication of binomial Surds. So when we say it's binomial, it means that either you're trying to add two Surds or you're trying to subtract one from the other. So what we are learning in this lesson is how we can multiply both. Now, bringing the idea here, we have this root of 2 plus the root of 3 multiplying the root of 2 and the root of 3 once more. So the same way you would expand your regular expression, algebraic expression, take the first term in the parentheses, use it to multiply the other parentheses plus the root of 3 multiplying the root of 2 plus the root of 3. So the root of 2 multiplied by the root of 2 gives the root of 4, which is 2, plus the root of 2 multiplied by the root of 3, you have root 6, and it goes on like that, root 6. Lastly, you have root 3 multiplied by root 3, root 9, which is 3. Now we have to add the Surd, similar Surd, which is root 6 and root 6, to give you 2 root 6. Then 2 plus 3 is 5. Moving forward to the other one. Now in this case, we have to multiply mixed Surd. The process is quite similar to the first one we had. So we have 4 root 7 multiplying 4 root 7 minus 3 root 3. Then we take this plus 3 root 3 multiplying 4 root 7 minus 3 root 3. So now we take just like we've explained in the previous video, you take the irrational part, you multiply 16, then you take the Surd part, you multiply. So for the sake of the explanation in this example, I'm going to leave this as the root of 49 minus, then this again goes as 4 times 3, 12, and root 7 multiplied by root 3 gives root 21, plus 3 multiplies 4, 12, and root 3 multiplies root 7, that is root 21. Lastly, we have a positive multiplying the negative, so you have negative, then 3 times 3 is 9, then root 3 multiplied by root 3 gives root 9. So as we've all known that the root of 49 is 7, so 16 times 7. Now there is a minus root 12 root 21 and there is a plus 12 root 21, so it basically goes to 0. So we are left with 9 multiplied by the root of 9 is 3. So this gives 112 minus 27, and that is equal to 85. Now one last thing, if you recall at the beginning of this lesson we tried to explain the idea behind binomial sort, and we said that it also works when you try to multiply the first parenthesis by the second parenthesis. So if you have to multiply root 7 plus root 5 by root 7 minus root 5, let's take root 7 as x and let's take root 5 as y. So we can now have x plus y, and the second parenthesis we have x minus y. Now this is difference of 2 square. That says that x plus y and x minus y expands and simplifies to x squared minus y squared. So which means that the root of 7 plus the root of 5 multiplied by the root of 7 minus the root of 5 can be written as the root of 7 all squared minus the root of 5 all squared. The root of 7 squared is 7. The root of 5 squared is 5. This equals to 2. And the same idea can be brought here by saying this is 4 root 7 squared minus 3 root 3 squared. So you make the individual square of what you have inside the parentheses. So this is 16 times 7 minus 9 times 3. So we have 112 minus 27, which is equal to 85.